Hi guys, welcome back to my channel. And this is the day 7 of DSA bootcamp. And as you can see, we have been explaining everything from day 1 to day 7. I've been explained everything, all the GFG and lead code problems, everything has been explained here over here. And please do like and subscribe and all the visualization, how the dry runs and the algorithms, all everything, the extra everything has been explained. Please like, share, and subscribe and support us. And I will be starting with today. DSA problem was number of atoms, and my current streak was 836. And let's go to the problem itself. Given a string formula represent the chemical formula, and this question was asked in I think let me show you where it was asked. Yeah, it was asked in TikTok twice, and this one, and Google and Apple, and this one. uh, how many times it is present, and recent 1 2 years back only this question was asked most multiple times, so that it is more important. And yeah, let's go through the problem. It's been given a string formula. They will give one string and indicate the formula representation of the chemical formula. Yeah, as we know that we already did +2 grade. During that time, there is a subject called chemistry, which consists of a lot of formulas like all chemical formulas like benzene, benzol, and sulfur, everything, every formula, and we have done few lab experiments as well. Though those formulas we have to do, we have to validate, and we have to we have to generate a particular formula out of it, and return the count of each atom, and we have to return the count of each atom. Basically, they will give one formula, and they will give one nested component also. We have to return their count of individual atoms itself. We know, right, in atoms having the standard formula. Atom element is always start with an upper character, and then zero or more lowercase letters, and representing the name of the atom. Like for example, hydrogen H, and sulfur, I think sulfur S, magnesium Mg. Those formulas indicate the atom elements, and one or more digits represent that the element count may follow. And if the count is greater than one, if the count is one, and no digit will follow. Okay, and for example, H2O and H2O2 are the possible, but H1O2 is not possible because there is no combination for this. But here we have a standard formula H2O and H2O2, hydrogen peroxide. H2O is hydrogen oxide, water. Mm, and there are two formulas are concatenated together to produce another formula. Basically, they will give like this some formula, and they will enclose with the braces also, and we have to multiply three the number of times the digits into the current count, so that we will get an final add up answer. It should not, the final result should not contain any braces, but the given questions contain braces and nested also. And the formula is placed in parentheses and a count optional by added to this formula. And as you can see, and return the count of all the atoms elements as a string, and in the following format, like first name in the sorted order, and followed by the count number of times the particular atom was appeared. Okay, if the count is more than one, you have to specify the number followed by the digit number, and second name in the second order followed by its count. Okay, and so on. The test cases are generated so that all values in the input fit into the 32-bit integer. All will be fit into the integer, so that we can take an integer only primitive version. So as it given stated, and we have to check for the constant. The formula length is 10 power 3, so that the solution can be accepted even n square solution also, because 10 power 3 into 10 power 3, 10 power 6, that can be mm, run on the server within a second. And the formula consists of English letters, digits, the braces also. And the formula is a valid formula they will give. not an invalid one. Okay, these all constraints have been given, and we can see H2O, and the count of the element is H twice and O single time. If it is single, I should not mention the one as it mentioned. If the count is more than one only, we have to specify the count. If the count is more than one only, we have to specify the count. Okay, and that's the reason O1 is not there. So just it. And H2 is there. We know hydrogen 2. And here you can see that uh, 2 there is a nested formula, nested atom. Inside outside we have an number. So we have to multiply each one of the components. So H2, Mg, and O2. These are the keys are sorted. As you can see, H the alphabetical order is 8, and M was 13, and G was 7, and O was 15. So it was sorted order. It was in. That's what the question states. See, have to written in sorted order. Um, yeah, written all the elements of the string, the following name, and you can see sorted order. The first name should be in sorted order. Okay, keys are sorted in here, and here the map representation of this component, and the written type also should follow the same. Like you can see K4 and 2 O14 S4, same thing has been displayed as an output, sorted keys. Okay, and K4, as you can see, for example, here the 2 is there, and 2 into 3, how much? 6. 6 into 2, 12. So that's the reason we call it O12. And here also we have another O, which will be at the 2 only, 2 category. So O12 plus O2 is nothing but O14. That's the reason we got O14. Number of times the atom appears. And K4 it's common, and N will be dealing with the outer of 2, so that twice or twice the atom was appeared. As how the S was 4, because of 2 into 2 it was nested of nested component, so if the running sum of the atom, the count will be the 4 for S. That's what the question. Let me go through the solution approach. There are multiple solutions we can solve by using recursion, and by using stack approach, and by using pre-processing. Those kind of optimization also we can do. And where is my that? Here we go. Yeah, basically we have to segregate. We have to understand the question, and we have to segregate the problem. So as the question said, the uppercase letters A to Z will be denoted as a group of U means upper, and lowercase denoted by L, and digit was grouped as an D. And we have left parenthesis, right parenthesis. How we can validate the formula? That's what we are deriving this. As you can see, the L group, nothing but lowercase group, followed by digits. Yes, it can be possible because there are some formulas Mg2 magnesium, how the lowercase letter is followed by 2. And there are, and also we can't form digits first and then lower 4. That is, there is no formula like 2H, nothing. Number should not be followed with any alphabet after that. That is not a valid formula. So, for time being, I have written all the edge cases, all the valid possible formulas. This is analytics is bit overwhelming, I know that, but it's important to understand the structure of the valid formula, how we can derive. Yeah, now I will be going with an recursion approach. Recursion, it was straightforward. Let me explain the intuition instead of this theoretical part. Yeah, I will be going with an explanation. Let me go through the diagram. For example, here we have, right, we given an input formula, input string. We have to just leave about the stack. Instead of stack, think about its kind of recursion. Each stack indicates the frame, stack frame, stack frame of the recursion call. Okay, and first of all we have to insert all the elements into the current stack. Whenever we encountered left braces, nothing but open part, then we have to, as you can see, all the input string has been added. Whenever we encountered open brace, we have to create a new empty we have to call and recursion function, so that this will be evaluated on the same stack frame itself, not on the main stack frame. So another stack frame will be created, and this will be evaluated on the sub stack frame on top of it, piling over the main one. And after completing that, when we encounter the closing one, then we can written back to the main one. As you can see, we are written back to the main one. See, as such 6. So we are multiplying into every atom into 6 times number of digits. And once we multiplied, we are storing back to, we are returning back to the function call is over. We are returning back to the main base framework, base stack frame, and we are appending. Here also we got another closing. So we are multiplying every atom, and then we are returning back to the main frame. At the end you can see we are getting some kind of in this kind of in stack. In order to sort at the question stack, we should use key map in Java, and in C++ we can use ordered map. That will suffice, so that keys are sorted and respect to order will be there, as it is a dictionary. Like Python, we have dictionary. Okay, so these are there, and at the end we can simply iterate through the tree map, or an ordered map, or an order dictionary, and then we can collect all the atoms, and we can append their count. As you can see, H14 Na2, same whatever we are appending, and we adding every element. At the final output will be generated. That's what the expectation. Now coming to the solution, it's pretty straightforward. I will be explaining. We have to initialize the stack, and yeah, this stack, right? Why I'm using stack instead of recursion? Recursion, it will lead up to the stack overflow. If the number is 1,000, that will suffice. Doesn't go to the stack overflow error. But if the number is 10 power 5, you will obviously get the stack overflow. In order to avoid that, we can simply use stack to simulate the recursion problem. We are creating one stack. In the stack, we are storing one hash map, and on the main stack itself, we are creating another nested stack. And inside nested stack, we are storing nested map, and we are storing that. Once all the computation is done, we are appending to the base stack itself on top of it. Same thing, the explanation we are given. And the stack we are creating, and we are storing map. String is the key, and integer is the count, atom and their count. And here the stack, the main base stack, and we will be creating one level, nothing but one stack from initially. For creating that, will be initializing new hash map and pushing to the stack itself, and we will be index to keep track of the current characters, and this is a global index, and we are parsing the formula, and we are checking for till it reaches to the end of the given string, and we are checking for the left parenthesis inserted into the new hash map to the stack, and it will keep track of the atoms and their count in the nested formula. We are checking for the left parenthesis, like whenever we encounter left braces, we will be creating a new stack from, and we will be calling to the respective again and again stack. Right, so that's the reason we are using recursion and simulating within stack, and we're creating a new hash map to store that particular data structure of that particular map. Data structure we are storing, and the data structure we are storing in hash map, and we are incrementing the count itself. As we move further, right, it's an open brace. We should move to the character itself. Whenever we encounter right parenthesis, we should pop out the top element from the stack and multiply the count with the multiplicity of the nested formulas. For suppose we got a formula, nested formula, and we have to multiply with the current running count. Here, when we encounter the right parenthesis, we are taking we are popping the current map, and we are incrementing, and here the multiplication will be done simply with the help of index, should not exceed to the length, and checking whether it is a digit. until we reaches the end of the digits, and we are multiplying. We are using multiplier as a string builder. We are appending all the digits present in the formula. We are appending to the multiplier and going further, and we are checking if the if we have the valid multiplier, it should be greater than 0, and we are passing it. Integer dot pass, it will pass the particular string builder concatenate number into the digit format, numerical format. And so once we got that, we are simply multiplying with the current running atom sum into atom count into the particular multiplier, and storing back into the current map in the particular stream. Simply we are doing this operation. Once we multiply the nested stack, we have to multiply back to here. Whenever we encounter h, suppose we have h, we are multiplying this to the nested stack count into the multiplier count. We are multiplying. Same thing we are doing here. And after that, right parenthesis is done. As you can see, this is the left parenthesis, right parenthesis, and this is where the we are inserting the levels. We are merging the levels here. And current map dot key set, for every key set we are merging. This is nothing but merging. This is merging step, and this is the multiplier steps whenever we encounter. For example, right, we have this one. Yeah, this one. This component nested of nested 6. And whenever we encounter 2, we are multiplying 6 2s are 12, and these all will be applicable to these two components. So the right closing brace will be handled like multiplying those, and this is the case we are merging to the top pile stack to the base stack. And otherwise we have to, it must be an uppercase letter, and extract the complete atom with the frequency updated the most recent hash map. And we are creating new string and appending the character index, and we are checking till it reaches to the, if it is content lowercase, we are appending to the current element, like for example mg, m is capital and g is small, so that we are appending handling that condition. And here we are checking for the current count with the help of char dot is digit till the current count reaches like 786 or whatever the number, and that will be appended and stored in the current count string. And here, if it is valid, we are converting into numerical format, and we are merging them. We are setting to the frequency. And once we did all those things, we have to sort the final map by using tree map. By internally it does all the keys, so in a lexicographical order, sorted order. This will be sorted, and as you can see, if whenever the frequency is more, we are appending their count as well. So final map dot get the particular atom, we will get a frequency count of a need, and how we are appending to the our answer. Answer is a string builder. It's a take constant time, and we are writing. The time complexity of this algorithm is n square, and space is order of n, as we are taking stack, additional stack. And now let me optimize this. As you can see, what we are doing, we are going from left to right, and we are pre-processing. If suppose mm, we encounter nested component, we are multiplying it back everything. You can see we are multiplying back with everything. This entire stack we are multiplying with the base one. It was taking too much complexity, too much. That's the reason it was took n square. Why can't we avoid that? How we can avoid that? We have to take it in deep observation. What was the deciding factor? As you can see, deciding factor is the numerical digits. Whenever we encountered right brace with a numerical factor, that is the deciding factor for all the prefix of those elements until it reaches to the left open brace. So this is the deciding factor for entire this. So why can't we iterate from the right to left in order to solve that? That's where we come the pre-processing, and the pre-processing is nothing but we are removing all the braces. We are doing one kind of an iteration where we are removing all the braces and we are doing the multiplication of operation from left to right in an, one line, one pass, and we are updating the running sum of it, multiplier of it, every index. That's where the, let me go to the problem itself. See here, you can see the reverse stack also will work similarly, but it takes n square time complexity. In order to avoid that, there is a technique called pre-processing, as you can see. Approach. This is the best approach. We have to take an int array which indicates the multipliers, all the multipliers initially will be 2 and this will be also 2. There is no character here. This is the multiplier, no need to calculate. Whenever we encounter any character or an English letter or a braces, then this will be matter. 2 into 2 4, we got 4, and here doesn't matter 4, here the 4, here the 4, and this is where the outer bracket, the sync is over. 2 complement is reaching up to this, and this is done. So we have to, this 2 will be indicating to here itself. From here onwards it will be belongs under this category. So we will be 2 into, and this will be the 1 itself multiplier. So in order to store the multiplier, we are taking one additional data structure, nothing but a valid multiplier, and storing into every index. We are taking a running multiplier. We have the diagram also. Let me check that. Yeah. Here, as you can see, what happening is that we are iterating from right to left, and we are taking one stack in the previous approach with the reverse direction. And we are taking a running multiplier. Initially, multiplier will be assigning to 1, and whenever we encounter any atom, we will be storing as a current atom, and the current count will be the 1, and we are storing in the final map. And similarly, this all will be done mm, whenever we encountered any digit, we have to check the current digits and we have to multiply to it. So 2 ones are 2. So H will be 2, and this is fine. And this 2, right? This 2 will be the levels will be storing here 1, and then we have to pop out whenever we encountered left brace. We have to pop out the earlier one, and we have to divide it by the running sum, as you can see. And here the 2 is there. Whenever we encounter right one, we have to add into our stack. As you can see, 2 was added, and the multiplier also got multiplied by 2, because the current level from the here onwards, this all section will be multiplied by 2 on top of the running sum. Same thing, 6. So same thing will be applied, storing and multiplying with 6. Previously it was 2, and 2 sixes 12, not 12. Similarly, whenever SH, everything was multiplied by 2, and whenever we encountered a right word 1, then we are dividing by 2. We are popping out the stack and dividing by 2. Same thing for this case also, we are making an additional data structure which is a preprocessor, like a pre-compute and prefix sum. This is important for the competitive world and also industries also. We have to pre-compute everything so that we can do in a single pass and linear time complexity. Okay, that's the reason. This is the preprocessor part. As you can see, this entire component is preprocessor. This entire component will be the mm, extracting the atoms from it and respect to count, and we are sorting it, and we are forming an output basically here. There are three components. Let me explain individually. The multiplier, we are taking an int array up to the indexes. For every indexes, we have to calculate the respective multiplier from right to left. And here the processing, the index always starts from right to left. As you can see, right will be the length minus 1. And we are taking current builder, and we should go up to the 0 only. And if it is current digit, it's a digit, have to insert into the current number. And whenever we encountered a letter, then the scan number was a count, not a multiplier, and we can discard it. How we can discard it? By reinitializing the string builder, we can discard the current number. It's just a count. Okay, whenever we encounter the right parenthesis, nothing but this, it's kind of a multiplier. The scan number was a multiplier and we can store it. So in order to store that, we have to check the whether valid or number or not, and converting back to the integer format, current multiplier, and we can run within current multiplier into run multiplier. So we can push the current multiplier into the stack so that every level we can pop it out and divide it by 2 to revert back the multiplier itself. And we are reinitializing the current number. Whenever we encounter left parenthesis, then the rightmost multiplier case to exist so that we will be popping out. See, you can see whenever we enter left this, the level is over. The particular level where multiplier is done, we have to pop out the stack of the previous level, and it should be removed from the running multiplier. So, and every time we have to reinitialize so that current number will be updated every time, and the running multiplier will be set for every index. And we are going further by iterating. We can use for loop also, that will suffer. So while loop also fine. So this is where pre-processing comes into play. At the end, we will be forming this array after pre-processing, right? Pre-processing will get this array, and from there onwards, we will start the extracting of an atoms. Here comes the final map, and we are traversing from left to right for extracting atoms. Atoms should not be reverse order, okay? Only the numbers should be numbers and multipliers should be right to left, descending factors, right? The uppercase letter we have to extract from the current atom, and we are checking whether it is an uppercase. Then we are taking current atom, initializing, and we are storing the particular current index. And for current count, we are going towards the current atom. We are appending to the current atom while loop until we reach the end. And this is where the count, current count, we are adding to the current count, appending to the current count if it is a number, and if we found that some numbers, some digits are there, and finally we update that particular stack with the help of this. If the current count is more than, if it is valid current counter, give me the current atom string, and this is your multiplier factor, and this is your count. We are counting the current count and also the multiplier respect to multiplier. So this particular map will be updated in a constant time operation and for every atom. And as we are increasing the, we are going for the next items. And finally, for sorting order, we will be using a tree map to sort, and string builder for result concatenating of atom followed by the count respect to frequency. If the number is greater than 1, we are appending to the answer, or else only the atom will be sufficient and we can get it at that. Time complexity will be order of n log n because of a sorting, tree sorted to entirely does n log n. And what algorithm uses? Remember, it uses that merge sort only, and log n time complexity. Space will be order of n as we are taking multiplier array, and also yeah, and also string builder. It is also component. That's all. Yeah, thank you. Please like, share, and subscribe.